Hello, this is Andrew. We're going to be looking at the advanced encryption standard for the project 2. Okay, so by this point, you should already have all this done, and be sure you watch this video with this lab document because the project 1 video and the document are meant to go together. So basically, students will create a web page of 4 functions that they have created. These functions will work together to perform the AES encryption on data and a key input by the user from the web page. AES consists of 3 distinguishable parts: encryption, key expansion, and decryption. And we're only going to be doing encryption in this lab. I don't think we have time to do key expansion and decryption. Okay, the web page will also use date-time functions. These are functions that already exist in PHP. You're just going to have to use them to display the dates and times. This is pretty self-explanatory. I can send you a video or something if you can't find the functions and figure out how to use them, but mostly this lab document is going to be talking about the AES encryption standard and the functions you'll need to create. Okay, why do AES in PHP? Well, it's a great exercise with arrays, functions, conditionals, loops. After all this, you will be an expert. So PHP is not the best language to do AES, but that's going to be a benefit for us for a number of reasons. One is, if I asked you to do it in C++ or Java, there'd just be a lot of code out there you could go and copy and paste in and you're done. So that's not good. I want you to learn the material. And also, this is going to let us really push PHP and see what some of the limitations may be of PHP. I hope you start to get that. Okay. And AES is really just super interesting, right? It's what secures the internet. It really makes the internet possible. See all these hackers, they're always trying to hack everything they try to do. They're trying to get around AES. Great hackers don't even assume that you can go through AES, right? So this is the outline of the procedure. So basically you're going to do 4 functions. There might be a little more, but I've actually done most of this add round key, and I think I'm going to give that to you guys. The mixed column and the add round key are the 2 difficult ones. These 2 are pretty simple. Alright, so that's pretty much it for that. So focus on the left side of the page right now. Stay away from the right side. Okay, so basically you have 128. This is a block cipher, right? Advanced encryption standard is a block cipher, and it's a block of 128 bits. That's your plain text, and that's your key, which is could be your password. Put in your password and your plain text, right? Well, let's go look here quickly. So here's a computer doesn't know. So for example, if we pick G, a computer only knows 1s and 0s, right? So they assign each character some value here. This is the decimal value. But this is the value that the computer sees, is this binary value. So let's say you have G. That sounds good. So they're assigning 71 to G. Well, the binary number of that is 4, 8, 16, 30. 64 plus 4, 68, 71. So you see that 71. Okay, but also, now that's one character, G, and you see that it took 8 bits, right? One byte, 8 bits. So it's also a hex number. So how many times does 16 go into 71? So 4 times 16 is 64 plus 7 is 71. So 4, 7. All right. I hope you remember your X numbers, but they just go, hex numbers, they just go 9, and then A is 10, B is 11, C is 12, D is 13, 14, 15. Okay. Pretty simple stuff. So you can see also that a letter, a letter has an assigned number, but so does a number. So G is 71, but 8 is 56. So you can, but it's also this binary representation, 56, right? Which is 2, 4, 8, 16, 32, plus 16, which is 48, plus 8, which is 56. All right, so, and then there's your hex number. Just divide that by 16, and you get 3 16s with the 8 left over. All right, so 48 plus 8 is 56. All right, so what this means is you can do an operation between a number and a letter. I mean, you can't really add a number with a letter or multiply a number or a letter, but you can do operations on the binary numbers and get a result. And that's what they do to encrypt data, right? So if you look here, all these symbols on your keyboard stop at about 128, so it's covered with 8 bits, all right? Really, it would be covered by 7, but they use 8. 8 bits, 8 bits is a byte. And that covers everything on your on your keyboard. Now, I've also pulled from this document, and this document is really good at just making it pretty clear. And here's one of the operations I was talking about, is the exclusive OR. So this is something you can do to 2 binary numbers. So one could be a G and one could be a 4. But you couldn't do anything to those in our world, but you could on the computer world with binary numbers. You could do an exclusive OR, for instance. And what is an exclusive OR? It just, if one bit or the other is high or on, then the output will be on. So this one is high, it's on, so the output is on. This one here is on, so the output is on. Now if both of them were on, then it's off. And that's what it means by exclude. It excludes the condition where they're both on. So it's exclusive OR. Now, of course, where neither one of them are on, then it's just off. So we're going to see that operation used quite a bit through this process. So if you go back here, now this, if you'd forgotten or never known, then this should make sense now. So you have this input of text, right? And it breaks it into blocks like this of 128 bits, which is 16 bytes, which if you go back to this character sheet, that's only 16 characters. So if you type 1WX space, 1WX space, that's 4. That's 4 bytes, right? So 1WX space would go in there, and then 5A 6B could go in there. So, and then you would fill up this block. It's the same here with the key. It could be, let's say, a password for now. So what's going to happen is your password may not be 16 characters long. So you have to have a padding function that's going to look at this array and say, okay, it's only a size of 12, so I need to add 4 more. So you're going to have to create a padding function. And then the same thing happens with the plain text. It does it by, AES works by blocks, like I said, of 128 bits or 16 bytes. And what happens is, maybe say you're going to send 8 pages encrypted of text. I don't know how many blocks, but let's say it's 1,000 blocks, let's just say. But then it's never going to land exactly on a division of 128 bits. Well, it might in rare instances, but usually it's going to be somewhere in between, right? So your last block is going to be short of data, so you're going to have to pad it too. So you'll need this padding function to create. Alright, so other than that, what we're going to do is cut out this. We're not doing key expansion, remember? So you'll enter a password, pad it, and then that password will go directly into these functions here. These are basically the 4 functions we were talking about. Not exactly, but you'll see in a minute. So there's an initial transformation, which is the round key, and I've basically done this one. So it takes this in and this in, does the exclusive OR, and gives you a state out. They call these a state. This is a state or a matrix, a block, any of those names. Alright, but what it really is, you know, it's 16 blocks of 8 binary bits, or 16 bytes. Alright, so then after here, you're going to go back into this set here with the key again, or the password, and you're going to go through some process in here, and you're going to do this whole thing like 9 times, right? And then you're going to come out and go through these, and then you're done. That's your ciphertext. So I know that was a little quick, but we're going to go more brief, more slideshow. We're going to go more detail here. So like I said, this guy on YouTube had done this video. I think he did it in Java. He actually did the code in Java. So his explanation was pretty good. So I think I'm going to have you watch that video as well. But okay, so like I said, I basically have done the round key. So that's your start. They're calling it a state. That's your data, right? So it goes in here. Oh, sorry. Previous. Your data goes into the add round key function, and your cipher key comes in. We're going to say this is the password. And if they're not 128 bits, then it has to pad it with something that the user chooses from the web page. And push a button and say, I want to pad it with 4s, or I want to pad it with 8, whatever. So the output of this will be the exclusive OR of this block with that block. And it will be represented in a hexadecimal notation. And it should be displayed on your page, but we'll talk more about that later. So then when you get here, you just want to go through subbytes, which you have a block in and a block out, and it does something to it inside. Same thing with number 2, 3, 4. So after that, you go back and do this again. Well, you do the round key, so you add your key, but in real life, this is going to be a different key because it's going through this key expansion process, right? But in our thing, it's just going to be the same key. It's still going to be the same key, okay? But in real life, the key would be scrambled as well. So anyway, for now, we're going back and we're going to do that 9 times. So you might want to have some kind of counter here. You may even want to have like a button where you can do it once, or 2 buttons. You can choose, I want to do it once or do all 9, or just a picture like this where you enter how many times you want to do it. So you might want to just make this pushable. So you push the blue box and it just does subbytes and then stops, and you look at your output here. You push this one, look at your output here, push this one. You get the idea. So anyway, it does this 9 times, right? In real life, add in a different key each different time through this exclusive OR process in the add round key function. Now, after that, it just does all of it again, but it skips the mixed columns matrix, and that has to do with the de-encryption process. but we're not going to go into that in this project. So then you add the final round key. So this will be exclusive OR. That's what this symbol means. So you'll add the final round key. And that's pretty much it, really. Let's go talk in some detail about some more of this stuff. So here's your functions. I just made a little list here of the inputs, what the function does, the outputs. This is high level, so it's pretty simple. This is just shift rows, performs matrix multiplication, does exclusive OR. Outputs, you can read through all that. The mix column, it comes out insanely scrambled block. Okay, so add key. Like I said, I've basically done this one, but you're going to have to, you're still going to have to work with it some to use it. So, but basically all we're doing is taking the 16, we're just taking the state and the key the key, not expanded key, and just exclusive OR in them together. So that's what we're doing. For the subbytes, this is really simple. It's just a lookup table. For those that are familiar with the lookup table in hex. So look at all these states are going to be in hex, right? That's what they're going to be in. If you remember hex is 0 through 15, which is 16 numbers. How many bits does it take for 16? 4, right? So 4 bits for one hex number. It takes 2 hex numbers for a byte. So each one of these blocks are going to have 2 hex numbers. Okay, so if your hex number is B7, so say you're looking in this block here and it's B7, then you're going to come over here and it's like B7. So you're going to just replace that number that's in there with A9. This is actually in linear algebra for your matrix algebra. I don't know if you've had that yet or whatever, but this is actually called an S matrix. So that's why they call it S substitution. But anyway, the shift rows, this is really simple too. So you're going to take the output from that substitution matrix, right? And you're going to put it in here, and it's going to be a block cipher of 128 bits. And what's going to happen is you're going to shift these rows here. So really, you can read through this, but it's pretty simple. So the first row, nothing happens to it. The second row is shifted left by 1. Okay. So the EC goes over here, the 90 goes here, the 4C goes here, and the 6E goes there. The third row is shifted by 2, so the EC goes here, the 46, the EC goes here, the 46 goes here, the C3 goes here, and the 4A goes here. So you can see it's just shifted by left 2. So the third column is shifted by left 1. By left 3, which is the same as right 1. So that's simple. So basically, you just grab. You'll do what's called, that's just a transformation matrix, really. So anyway, then you're going to do the mixed columns, and this is a more difficult one. This is your third function. So basically, I have the complete document that shows you how to do it, but basically B1, there's going to be another matrix here, right? And you're multiplying these two matrices together to create another matrix. So the way you do matrix multiplication is you do B1, see where these two are intersecting? They're intersecting at this point. If I were using this row here, then they would be intersecting at this point. But right now they're intersecting at this point. So B1 times 2 plus B2 times 3 plus B3 times 1 plus B4 times 1. Well, remember G times 1 or whatever, what number did we use? G times 9 doesn't mean anything, right? But you can't exclusive OR the numbers, so that's what you're going to do. So you're going to do B1 times 2 exclusive OR with B2 times 3. So that's what you're going to do. But remember this, in the background, you're using hex numbers or decimal numbers, but in the background, it's doing the operations on the binary numbers, okay? So B2 is the same thing. So instead we're looking at this this row that intersects here at B2, right? So it's B1 times 1, B2 times 2. That's B2 times 2, B1 times 1, B2 times 2, B3 times 3, B4 times 1. That's it. So that's matrix multiplication. And what that does is it just really scrambles the data. And what you actually have in here, if you think about it, is this data has the key in it as well because it's been exclusive ORed with the key. But that key has gone through an expansion process. So the key went through an expansion process. It's mixed in here, and now it's mixed up in this matrix as well. And not only that, but that happens 9 times, right? It goes through this whole process 9 times. Okay, then after the 9 times, it just does the sub byte, shift rows, add key, and then you're done. So, yeah, that's pretty much it. But now you need a web page, right? So you got to turn this into a web page. And, okay, this is not the prettiest thing in the world, but it gives you the ideas. I think you should have something like this flowchart on your web page that shows you going through. Like I said, you could even have it counting as it's going 1, 2, 3. You might want to slow it down or something, or just have a button that you push like one time. Sorry. 1 time, 2 times, 3 times, 4 times, something like that. Here's your pad, all right? So say your key is entered and it's only 12 characters. Well, you're just going to have to pad by 4. So you put in a number that you want it to be padded with, like 3 or whatever you want it to be padded with. Same thing here. If your text is not actually 16 bytes, then you need to pad it. So then you should also show this on your web page, right? These tables that will show the input. So you had the data here. It's going to be in this table format in hex, and then it's going to go in here, and this is going to go in, and then coming out is going to be this guy, right? This is your output of add round key, and it's going to be in hex, and then it's going to go back into subbytes, and then you're going to have the output of subbytes, which will be this, and it'll go back into shift rows, and then the output of shift rows, and it's going to go into mix columns, and then you're going to have the for loop, right, that does that 9 times, and then you're going to call subbytes again, shift rows, and add round key, and then you're done. So like I said, I got so excited about it. I did a lot of add round key today. I'll just let you have that code and use it if you want. Just look at it and try to understand it. See if you want to do it totally different, or you want to just basically use what I did. Either way, I don't really care. It's just to help you out. I had fun doing it. I hope you have fun doing it too. Alright, so with that, I think I'm going to wrap this up. I just want to make sure you're aware of the 2 documents. This one I pulled from, and really look at this one. It is really good. It makes everything really clear, especially when you get to the mix column matrix. It really shows you how to do the operations, so you really want to focus on that here. Just do these operations, right, for each thing. what else can I say? Oh, there is one other thing. I think there was an error on this one. He's saying, I think he's got this backwards when he said shift left and shift right. I'm pretty sure he's backwards. His numbers are right. So this is shifted one to the right. Yeah, see, this is shifted to the right, but he says to the left. So this is right, but this should say shifted to the right, and then this one up here should say shifted to the left. Yeah, he got those. So that's the only error I've seen in this document. So other than that, it really is a great document. This one seems to be good too, although I don't know if I read it whole thing. Yeah, I think I did. Yeah, I did. I was pretty happy with this one. You can also, for those that are interested, it goes into the key expansion. Like I said, I certainly don't think people on this course couldn't do this, but I just don't think we have the time to do all this, so I'm leaving that out. Alright, with that, I hope you guys have a lot of fun with this. I know I had a lot of fun making it and doing the first function there, the add round key. Alright, thanks.